In this screencast, we're going to learn about inverse functions. And you could think of inverse functions as functions that undo what the original functions do. So, for example, if I've got a function f in terms of x, and it says take every x value, multiply by 2, and then add 3 to the result, the inverse is going to undo that in reverse order. So the last thing you did was add 3. So the inverse function, and we write it with f with a little -1 there. That's not f raised to the -1 power. That just means f inverse of x. Okay, so the last thing f does is add 3. So the first thing the inverse will do is subtract 3. And then the first thing the regular function f did was multiply x by 2. So the last thing we're going to do is divide everything by 2. So that's the inverse function of f. It undoes everything that f does. Now that can get kind of complicated trying to figure out the reverse order of the opposite operations. So here's what we do to find the inverse of a function. 5 steps. You replace f of x with y. Then you switch x and y. So everywhere there's an x, you're going to put a y in its place. Then you solve for y in terms of x. And the answer is going to be your inverse of f. And here's something that's important. The domain of the original function becomes the range of the inverse function, while the range of the original function becomes the domain of the inverse function. So let's do it with this example. We have a function f that says take the square root of x minus 3. All right, so I'm going to say y equals the square root of x minus 3. That's step 1. Then step 2, I'm going to switch x and y. So x equals the square root of y minus 3. The next step, solve for y. I'm going to square both sides, solve for y, and our inverse function is x squared plus 3. Now, here's something really important. What is the domain of our original function? Well, remember we can't take the square root of a negative number, so x minus 3 is greater than or equal to 0, so x is greater than or equal to 3. The range is going to be, well, if I put in the lowest value of x, which is 3, I'm going to get out the square root of 0. So y is going to be, or f of x, y is going to be greater than or equal to 0. So our range is greater than or equal to 0. Our domain is greater than or equal to 3. And what happens is, for our inverse function, they're going to switch. So our domain becomes x is greater than or equal to 0, because that was the range of our original function. And the range of our inverse is going to be y greater than or equal to 3. And if we graphed this, since I can only put in positive values for x, this is going to be a parabola, but it's only going to be half a parabola. And it's going to look like this. And you notice that the range is greater than or equal to 3. So the inverse function only includes the right half of that parabola. All right, so it turns out that only what we call one-to-one functions have inverses that are also functions. And a function is one-to-one if no two elements in the domain correspond to the same element in the range. That sounds complicated, but it's really not. Graphically, what this means is it passes the horizontal line test. It's like the vertical line test for a function, except we use a horizontal line. So I've got 3 examples here to determine if a function is one-to-one. Here is x equals y squared. Well, guys, look, this fails a vertical line test, so this isn't even a function. So it's not going to have an inverse if it's not a function to begin with. That's not a function. My handwriting is terrible here. Sorry about that. Okay, now this is a function that passes the vertical line test, but notice it fails the horizontal line test. Okay, we hit it in more than one place with a horizontal line. So this is not one-to-one. Okay, now this one, y equals x cubed. Okay, this passes the vertical line test. No matter where we hit it with a vertical line, it hits it in one place, and it also passes a horizontal line test. A horizontal line will only cross this graph in one place. So this is one-to-one. How can we tell algebraically if something's one-to-one? Well, if f of x1 equals f of x2, then x1 has to equal x2. So let's look at this right here. Determine algebraically if f of x equals 5x cubed minus 2 is 1 to 1. And if it is 1 to 1, let's find its inverse. Okay, here we go. So f of x1 is going to be 5 times x1 cubed minus 2. And f of x2 is going to be 5 times x2 cubed minus 2. So I'm going to set these equal to each other. That means I'm going to have 5 times x1 cubed minus 2 equal to 5 times x2 cubed minus 2. And hopefully, if I do a little algebra, I can make x1 equal x2. Well, the first thing I can do is add 2 to both sides. So that's gone. And now I have 5 x1 cubed equals 5 x2 cubed. Well, now I can divide both sides by 5, so that's gone. And I get x1 cubed equals x2 cubed. And from that, if I take the cube root of both sides, I get x1 equals x2. So yes, this is 1 to 1. Now, when would it not be 1 to 1? Well, what if instead of having it cubed, I had it squared? Then when I take the square to both sides, I'd have to do plus or minus, and x1 would equal plus or minus x2. So in that case, if it was 5x squared minus 2, it would not be 1 to 1. Okay, and then the last thing we're going to look at is verifying if two functions are inverses of each other. So let's say that I have two functions, f and g, and they're both 1 to 1 functions, so they have inverses, and it turns out that when I put g inside f, that's a composite function, remember, f of g of x, and I work it out and I end up with just plain old x. And if I put f inside g and I work that out and I get plain old x, then it turns out that g is the inverse of f and f is the inverse of g. So we're going to verify that these two functions here are inverses of each other. So let's do f of g of x. That means I'm going to take this entire function g, put it in for the x in f. That's going to be 3 times the function g plus 5. Okay, so my 3's cancel, and I end up with x minus 5 plus 5, which is x. So far, so good. Now let's do g of f of x. So now, let me erase this. We're going to take all of f and stick it in for x in the function g. So that's going to be 3x plus 5 minus 5 all over 3. In my numerator, I'm going to get 3x, because plus 5 minus 5 cancel, over 3. 3's cancel. I get x. So yes, f of g of x is x, g of f of x is x. So f and g are inverses.